This is Saranya, and today I'm going to speak about engineering chaos for resilient application, a game day guide. Bit of intro. I'm a senior software engineer at Harness and maintainer at Litmus Chaos, which is an open source chaos orchestration framework. And I've been contributing to this project for more than 2 years, and it has been an incredible journey so far. So moving on to the agenda today. We'll be talking about resilience, the chaos engineering. Like I'll be introducing chaos engineering and why is it important, and then we'll be discussing one of the typical way of practicing chaos engineering, that is game day. I will talk about its elements, and at the end we'll actually carry out a game day, and we'll discuss what are the good practices that we can follow. So moving ahead. Yeah. So starting off with what is resilience. Resilience is basically a systems ability to sustain a fault, and for example, let's say you inject any fault and the application goes down. So the application it should be resilient enough to bring itself back up. Like taking an example, pod gets evicted from your node. So what is its state? Is it healthy or not? Has it bring itself back up? So if it does, so it's resilient. So similarly, it goes with node and memory leak as well. So that was a very brief definition what is resilience, and moving on to the outages or downtimes, which are expensive, and not just in terms of money, but also there are secondary aspects to it, like loss of customer confidence, brand integrity. So it also, these secondary aspects are equally important and take a hit. So one way to avoid all this is by entering into the practice of chaos engineering. So with that, I would like to introduce chaos engineering, which is a process to testing distributed applications in a control environment. So the goal here is to identify the weaknesses through intentionally injecting chaos in a control blast radius, and ensure that your application behaves behaves properly in unexpected situations. So I'll talk about the basic flow, how chaos engineering you can carry out. So the basic flow is you start with identifying the steady state conditions. So steady state condition is a desired behavior of your application in a given scenario when the system is healthy. So you need to have those metrics to identify what is the desired behavior of your application. And once the steady state conditions have been identified, you choose the fault, the chaos faults or experiments which you need to inject, and you introduce a fault, and then you check whether the SLOs or the steady state conditions are met or not. If yes, then your application is resilient, and if no, you just identified some weaknesses, you can go ahead and improve upon it, and this loop continues. You can then again come to identify the steady state conditions and introduce a fault. So you can add it as a practice in all stages of your development. So so this was a very brief use case, how you can practice, but it is typically practiced, one of the typical ways of practicing chaos engineering is by running a game day. Game day, as its name suggests, it's gamifying the chaos experimentation. So it seems like a very fun activity, but it's a rather very important, intense and serious event. You need to take a lot of approval from from different levels, and most of the important stakeholders are present, and a lot of action items are generated, and post game day, you if the weaknesses are found, a lot of discussions. So all these events are pretty intense activities, and so it's an event where multiple people come together, carry out. So they decide upon what applications or services you will be targeted, and then you decide upon the chaos faults. that you will be injecting against your application, and then you discuss its technical impacts. And there are other checklist items that I'll be talking about, which you need to look upon while carrying out the game day. So let me share the elements. So there is some checklist that we believe that, like, as a game day guide. Yeah, so these are some of the checklists that we believe, like, we follow during our game day. Of course, you can all improve upon it, and yeah. So starting off with the first point, that is the game day participants. So first of all, you need to decide who are all should be present during the event. So it actually depends upon what environment you are going to carry out. So let's say you are planning to like carry out a game day in dev environment. So the developers or the QA personnel should be present during the event. And let's say you are planning to do it in staging, the shared namespaces where other people are testing their own application. So if you're planning to carry out there, then QA, like DevOps and the SRE teams, they need to be present. And lastly, the prod environment, which is the most recommended environment to practice game day, because you get the real time load, right, and scenarios are all real time. And so it of course the risk is very high in this environment, but you get very fruitful and efficient results by carrying out game day in a production environment. So for this, you need to take a lot of approvals, and the main customer success managers, account managers, and the main SRE teams, they all need to be present during the event. And next, moving on to the next, that is environment description. So you have decided the environment, but you need to decide when to carry out the game day. So you won't be like running a game day during peak load on a Monday morning, right? So you need to decide when you need to figure out when is the load is when the load is less, like a weekend or a Friday night. So you can carry out during that. And next is workload description. So workload is you need to identify the target applications, the services that you are going to inject the chaos experiments against. So with this, I'll be explaining I'll be mapping each of the next point with the game day that we are going to carry out now. And starting off with the workload, let me share. So this is an online boutique app application, which is a demo microservice e-commerce application provided by Google, and it has all the basic functionalities like the currency converter, and you can change the quantity and add to cart. There's a cart. This is the cart service, and there's the checkout service, the ad service. So all the basic flow of an online e-commerce application is there. Let me show you the deployment here. So this is the deployment. So the application has been deployed in boutique namespace, and here you can see all the microservices like the ad service, cart service, checkout, and all. And there's one load generator here, you can see. So this is this comes with the application. So this is I'm running it using the default configuration. Since I'm not doing it in a prod environment or any live environment, right? So to simulate a load, like a synthetic load, I am currently using this with the default configurations. I have already showed the application, and this is just a basic architecture of the application. That is you start it from here, browse the products, and currency converter, then the cart service and all the basic functionality. You choose the units, and then you proceed to the checkout page. So that's the diagram. And so once the target applications. Oh yeah, one more thing. So here today we will be targeting this service, cart service deployment. So we'll be targeting this particular microservice, and we'll see how the complete website or application behaves during the chaos injection. So next is the defining of steady state. So as I've already mentioned that you need to identify the steady state, like you need to make the hypothesis, steady state hypothesis. You need to, which after chaos injection you will be validating if your requirements are met or not. So you need to have that metrics or the stats that will tell you that the application is healthy. So for that, so since today the chaos experiments that we'll be running using is on are the litmus chaos experiments. And so there's a concept of probes which are like I'll be talking about it in detail in a little later, but like as an intro, like the probes are the pluggable checks which help you validate your steady state hypothesis. So these checks you can add it pre-chaos or post-chaos or during chaos injection. So I have this probe setup that I'll be displaying it in a while. So that's the for now the basic steady state validation would be during the chaos injection. Your application is running seamlessly. All the events, like all the services, are accessible to you. And yeah, next is the list of observability aids. So for observability, I have this Grafana dashboard setup. And next is the Prometheus. I have this Prometheus metric setup that is like going to take the metrics from the chaos results that like post injection, and then it will export it to Grafana, and we can see in real time during what happens during the chaos injection. So for Grafana, I have this dashboard. Yeah. So here, this is the Grafana dashboard. Okay. This is the Grafana dashboard. Here you can see we have the front-end QPS, card QPS, and the access duration. So as I like earlier I've mentioned that we are I'm having this synthetic load generator. So due to that, we can see some of the query that is being hit. So this is the dashboard, and we are using Prometheus matrix, which we'll be seeing during the chaos injection. Yeah. So next upon the list is list chaos experiments. So we have the target application, and now we will be deciding upon what are the chaos faults or experiments that we are going to inject. So like for this demo purpose, since like we are in a time crunch, I'll just choose a basic one, that is the pod network loss experiment. So what it will do is like you see this card service. We'll do a packet loss, a pod network loss on this particular service, and we'll see the impact upon the whole website. So next is the defining of guardrails. So you have the experiment, you have the fault, and you have the target application. But do you want, like, how will you decide when to inject the chaos, start injecting chaos? Like, is it now or it's 5-10 seconds, 10 minutes later? So there need to be like we should be having some proper checks, the pre and post chaos checks that we say. Using that, it will verify first, on the like pre-chaos state, it will verify first that if your application is in the desired state or not. If it's not, like you can get some unwanted results, right? So yeah, so these checks need to be happen before the chaos injection, and then post chaos injection we also need to have. So like once the chaos experiments are injected, done, like completed, and it has got reverted, we need to run these checks to verify if the application has went back to its original healthy state or not. So defining the guardrails, so this checks can also be added using the health check probe that I'll be explaining while like explaining the whole experiment manifest. So this can be checked using the probe. And next is the mitigation strategy. So you are carrying out a game day, let's say you're carrying out a game day in certain environment like production, and there is some weakness and the bug, and the whole application goes down. So you need to have certain playbook to bring it back to its original state, right? Otherwise you can get customer calls, and yeah, that would be like not a good user experience, like customer experience would get degraded. So you need to have this have a playbook to like roll back all the changes. So that's the mitigation strategy. And next is the orthogonal requirement validation. So it's kind of related to the previous one. So like if you need to validate certain events during a chaos injection, let's say like the basic one is, let's say your application went down and you need to have proper alerts or notifications, so that will like inform you that this has gone down or this particular event took place. So this can be in the form of like Slack notifications, or Jira issues, something like that. And next is the introduction of chaos platform to stakeholders. So with this, I would like to introduce the harness chaos engineering module, like in short we call it as HC platform, in which we are going to carry out the game day. Yeah, so here I'll just go ahead and create a game day. So starting with, you give a name, make sure it's something meaningful, like boutique game day, boutique application. Next is you need to, it's visible, okay, just zoom in a bit, yeah. So next is the objective. So you need to define what is the objective of your game day. Let's say like there are teams that who want to just explore the possibilities of the game day or the chaos experimentation. So next, like they can choose as exploratory, or you want to train your teams like a fire drill, right? So you want to train your teams like for any unexpected behavior or any such situations where the application suddenly goes down or something like that. So that is the training of teams. And if you want to validate past outages or verify observability, so you can choose according to your own requirement. And next, description you can add according like your own requirement. And then next step is choosing a chaos experiment. So I can choose any chaos experiment from the chaos hubs. So let me talk briefly about the chaos hub. Yeah, so the chaos hub is basically a single source of truth, a repository where you can store your own chaos experiment. You can like make changes and edit your experiments, add. So this kind of works as a single source of truth. So I have these many hubs connected, but you can add your own chaos hub. So this is like a Git repository. You can make your own and add it. So I have this, let me check. This is the Gameday demo hub. This is the chaos hub that I'll be using for selecting the chaos experiment. And here, if I scroll down, okay. Yeah, so this is the Gameday demo hub, and I'll select the cart network loss experiment. And next is like I'll select the target infrastructure where my boutique cart application is sitting. So this is the boutique Gameday infrastructure, and I'll just add this experiment. So you can add multiple experiments. You can run it according to your own schedule. And but for now I'll just add just this one, and I'll create the Gameday. And I'll start. So with that, the game day has started, but you need to run this particular experiment against this application, against the boutique cart application. So I'll just run this chaos experiment, and if I go here, okay, so here you can see the chaos experiment has started. So the first step is like the chaos fault, the template. It pulls the chaos fault template from the hub that I just showed. It will first pull the fault, and then it will install it and map it against our own like the boutique cart application, the target app like service, that is the cart service. So that is the first step. It will take some time. And next is like once the installation is complete, there will be some, like I talked about guardrails, right? So there will be some pre-chaos check that will happen. Yeah. So the second step is chaos injection, but before chaos injection, there will be some pre-chaos checks that will be done to check if the tunables, the target app labels that we have provided is correct or not, if the application is in healthy state or not. So let me check the Grafana. Yeah, here you can see these red area, right? So these are the annotations coming from the Prometheus metrics that I have set up. So it's like this we can say during the chaos injection what is its behavior. So it will take some time, but meanwhile I can explain the manifest experiment itself. If I go to this cart loss and experiment YAML, here as already mentioned, this is sitting on top of Orgo workflow. So here we have 3 steps. First is the installation of chaos fault that I mentioned, and this is the chaos injection step, and next is the alert notification step that it is a custom step that we have added, which will kind of send notifications to my Slack channel and mentioning like if any experiment has passed or failed. So that will give me some details. So in the meanwhile, if I let me check if it has started or not. Yeah. So here you can see the QPS is going down, and it's the front end QPS and it's the card QPS, and the access duration, that is the latency, is increasing. And if I go here in the application here, I just targeted the card service application, right? But here you can see none of the other services are accessible. There's a loader that is loading completely, so the whole application has gone down. So like taking an example, let's say I'm watching something like watching a movie on Netflix, and the streaming service suddenly goes down, but that shouldn't stop the other members of a family to browse the movies, right? But here you can see I just targeted the card service, but the whole application went down and the customer experience gets degraded totally. So that is some weakness that we just identified, and we can like take a note on it, and we can like work on fixing these issues. So that was the experiment, and let me see if the experiment has completed. Okay, so yeah, here you can see the app is starting to come up, but this particular step is still running. But this is because of the post chaos checks. So after the chaos injection is done, it will run the post chaos checks that I'll like to map it with the guardrails that we have already talked about. So that's the thing, and yeah, I guess I have got the notification. So this is the alert notified that I will be getting. If I go to this particular chaos injection, here as I talked about, these 2 probes, that is the health check probe, it's like the guardrail that does the pre and post chaos checks. So it has passed, but this prom probe, which is the Prometheus probe, it has failed. So Litmus provides us 4 kinds of probes. That is, first one is the CMD probe, and HTTP probe, KTS probe, and the prom probe. So as the name suggests, it is the Prometheus probe that has just failed. So here you can see the hypothesis. So this was the hypothesis. So we believe that the hypothesis was that the application latency should not be more than 50 milliseconds. So that was the prom query. If I go here and explain it so this is the chaos experiment manifest. Yeah, here this is the prom. Yeah, this is the prom query that we added, and the hypothesis here, it is targeting the front end service, and hypothesis here is the latency should not be more than 50 milliseconds. So as we saw that the whole application was not reachable, so the prom probe failed. So that was the hypothesis validation we just did. And if I go to my Slack, yeah, so this last message, so this is the alert notification, that custom step that we added. Here you can see that this is the experiment name, the fault that we did, pod network loss, and the fail step, if there is present, it will send the details, and the chaos duration. So as an improvement, we can all add logs, we can attach logs, or we can create Jira tickets, Jira issues, and attach logs, like adding the fail step. So yeah, so this is something that we added. And so this experiment has been completed, and coming to the game day. Okay. Yeah. So here you can see that this particular experiment has been completed, and this is the resilience score of the application. So resilience score is like it's like total probe success of a, like resilience score of a fault is like probe success percentage multiplied by the weight of the application. So the default weight for each fault we are providing is 10 here. So since one of the probe got failed and one got passed, so we have this resilience score as 50. And once the game execution experiment injection is complete, you should add some notes, like these are some basic questions if your system met your expectation, or like past incidents, or like you can add your own observation, you can generate action items, and you can like this will keep a tab of all your past game day runs. So that is something regarding the game day. But we saw what happened during the chaos injection. So I would like to explain this chaos experiment manifest a bit. So here I've the steps I've already mentioned. So next is, this is the experiment fault skeleton and with default RBACs and all. Next is the chaos engine. Yeah, so this is the chaos engine, which is responsible for binding the target application with the chaos experiment, which like it spins off necessary the required services or pods to like inject chaos. And since the target application, so to target a particular microservice or deployment, you need to provide the particular like app namespace and app label. So in this case, it's the card service. The label of this of the card service deployment is app is equal to card service, and the kind is deployment. So basically here you are trying to target a deployment with app label app is equal to card service in boutique namespace. Next is the experiment. So here these are some of the default tunables, but you can like tune it according to your own requirement. Here this is the like total chaos duration, how I have added it like 60 seconds. Then the network loss percentage and the runtime, other details, and pod effect percentage. So like let's say if you are having four pods of particular deployment, so you want to target any two, so you can give it 50. So that's the experiment tunables. And next is the prom probe. Sorry, it's the health check probe. So this is the guardrail. So this is kind of the type of this probe is CMD, and it is checking. There's a health check microservice that we are having. It is checking if the like application is healthy or not. So that is the probe. And next is the prom probe that I have already mentioned. And third step was the alert notify step, which is like the custom step that we added. Like it sends the necessary experiment execution details. And yeah, so this is the Slack URL and all. So this is how you can carry out the game day. And let me check if we, so this building of chaos experiment execution is done. Now we found the weakness, so we can go back and perform the root cause analysis. For that, identify the next action items, and like once these are all fixed, we can test all the like all the fixes that we have made. And then at last we can take up the Q&A, like the game day, whatever who all are present, they can take up the questions. So this this is how you can carry out a game day. And like you can obviously improve and add more checklist to this. So yeah, that's it from my side. I hope you found this insightful.